Alright, in the previous video we looked at different sets of numbers, of which we talked about relational and irrational. So in this video we are going to talk about just relational and irrational specifically. So without even wasting our time, let's get started. Okay, so when you hear of the word relational, so a relational number is a number. So we'll talk about relational now, relational numbers. Okay, so relational numbers are numbers that can be expressed in the form of a over b, where this b should not be equal to 0. So we don't want in a situation whereby b is 0. We don't want that, because the number will be undefined. Any number, say 2 divided by 0, that is undefined, or it is just discarded like that. All right, so it's undefined. So from there now, since we are saying it is undefined, so for rational there will be a number that is expressed in the form of a over b, where b is not equal to. So for these relational numbers so we'll have repeating, so they will be repeating, like let's say 2.2, 3, 4, 5, 6, 7, 8, 9, 10, like that. All right, so this is a number, like say it's 2.2 point something something. So this number, this is, we don't know whether it's relational or irrational. All right, so how are we going to know? So for relational, so these are repeating decimals, but they are not terminating, so they keep on like that. So if they are repeating and not terminating, so say if repeating and not terminating, meaning that those things are irrational. So that set of number will be irrational. Okay, so and if repeating and terminating, all right, so if repeating and terminating, then they can be rational, so we'll say rational numbers. All right, so again the other case is if repeating and so they'll be repeating. So if repeating and not terminating, so if they are not repeating and not terminating, then that will be let me give an example. So that will be irrational. So when we say irrational, let me lab this point so that I can have where to light. So if we find a number to say 2 point, let's say 6, 1, 2, 3, 4, 5, 8, 9, 7, 6, they keep on like that, and the pattern changes. That's what we call now irrational. All right, that's irrational. But if they are repeating to say 2 point, let's say 3, 3, 3, 3, 3, 3, 3, 3, now that will be irrational, because the pattern can be traced. So those ones we call them rational, and those ones which whereby the pattern can't be traced is to say this is what was repeating, then that will be what we call irrational. But if you see a pattern changing, just know that that's irrational. All right, irrational, rational. So those are the numbers: irrational, rational. All right, so they're very simple. Now we'll get into reversing. We'll start first with the rational numbers. So questions will be coming to say express in the form of a over b, where b is not equal to 0 for rational numbers. All right, so let's say, for example, we're given a question to say when you see a question, let's say 4.234, like that, again 3 4 3 4 3 4 3 4, just like that. So these numbers will be now what? They will be rational because the pattern can be traced like that. A pattern is 3 4, so it was changing by 3 4. So those are what we call now rational numbers. All right, so we'll find them in that form, and will be asked to what? To express in the form of a over b. So how do we do that where b is not equal to 0? So how do we do that? For example, express the following: express the in the form of a over b, where b is not equal to 0, like that. So what are we going to do? So we are going to do this. All right, so we are going to do this. For example, question 1, let's say 0.3 bar. So meaning that this question was repeating like that. They were just 3's to infinity. So if we have a number like this, we need to reverse in the form of a over b. So what are we going to do? There is a way of doing it. Of course, we can say this is 1 to 1 decimal place, so that is 10. You can say that, but we are not allowed in this case. So there is a way we solve them. So let's get started. So the first rule that you should do is first make sure the independence number, make sure that independent number comes to the left side of the decimal, left side of the point, or left side of the point, like that. All right, so make sure that the number that is independent, in this case we don't have a number, you don't have a number that is independent, then what do we do? Make sure the number with a bar cross the point to the left side as well. So it's always left side as well. All right, so that is it. So now if for this one now we don't have independent number, so we just make sure that this one crosses. So remember they were a lot, so they 0.3 like that, they keep on like that, you get the point. So we just use 1 and take it to the other side. Make sure that one pattern is taken to this side and remain with another pattern this side. All right, here is a point. Make sure that this pattern which had 3 crosses the other side, and also the other pattern will still remain there. That's what will represent you on the right side. So let's get started. So we say let x be equal to 0.3 bar, like that. All right, so you don't have an independent number whereby you can take to your left. So what you do is just take once the same a number with a bar, the same pattern that you have just traced. You have traced this pattern to say 3 3 will continue like that to your right. So we multiply number by what? You just check here, the point is here, so you write 1 there, and this 0 will represent any number there. That's 10. Now we can know that you are doing 10. All right, so that's how we do it. So you're saying, so this will be just 1. all right, because there's nothing here, you have done everything. Your independent number in this case is 0, and it is this side, and also a bar is just this side. So what we do is, the second equation now say multiply. You tell them to say multiply 1 by the number that you want. In this case I'll say it's 10, because I want to move the point to the other side. So when you multiply that x to 10x, all right, so x will be 10x like that, then is equal to this one will be just 3 point. Since it was 3 bar like 3's were continuous, so you write 3 bar like that. You are done. So you have moved this 3 there to the other side, then the other 3 has remained. So what you do now, this is how you can 2 like that. So you tell them to say subtract what? Subtract 1. So subtract 1 from what? From 2. all right, so that's what we do. So what we are going to do is, I'll write the 2 1, which is 10x is equal to 3.3 bar, like that. All right, so the one it was is equal to 0.3 bar. All right, so when you subtract this, we are going to have what? 10 minus x, 10x minus x, that's 9, right? Then what is 10 minus 3? That's 0. So that will be just 3. So you divide throughout by 9 like that. All right. All right. So you are going to read that that will be x is equal to 3 over 9, which is x is equal to 1 over 3. So when you divide that, it will give you 0.3 bar. So in short, forget about this, the answer is 1 over 3, just like that. So that's in the form of a over b, like that. All right, so that's about this one. So simple. You can pause the video and copy, and also solve it after you watching the video. Pause the video and watch it. All right, so let me give you another example. So if we have another example like this, let's say we have now 0.13 bar, like that. So I want to express it in the form of a over b, where b is not equal to 0. all right, so what we do, first thing we say let x be equal to 0.13 bar. So let's follow the instruction now. The instruction 1 was independent number should be on the right side. So how are we going to take this one to this point here? I mean to your left. So what you do is you multiply that number by 10. It will go once. Like a point will come here once. I give you 100, then the point will come there. So by 10 the point will come there. All right, so that's what we'll do. So multiply it by 10. So you say multiply times 10, so by 10. So we multiply by 10, that will 10x, all right, is equal to the 1 now come this side, then 0.3 bar. So once you make this, then that's your number 1. All right, so we have solved everything. What you want, the first goal is to the first traced number, which is the repeating pattern, to be on the left side independently. Then the other one is to take the same pattern traced on the other side as well. So that's equation 1. So how are we going to move now to bring this again, to bring it there? You multiply again times 1 times 10, so that it will remain with it. Remember, it was, in short, the 3 we are just keeping, so we just want to bring the other 3 to this side of the point. So you multiply again times 10, so that will be 100 x. So we say now, allow me to write this, we multiply now, you write like this, multiply 1, equation 1 by 10, so that you move that one to the other point. So that 100 x is equal to 13.13 bar, like that. So that's our equation 2 now. All right, so we subtract, you tell the sub 1 from 2, like that. All right, so 2 it's 100 x is equal to 13.3 bar, like that. So you bring your 1 is now 10x is equal to 1.3 bar, like that. So you subtract, when you subtract this, it will give you, this plus is 0, this plus this is 0, this 3 minus 3 is 0, then 13, which is 3 minus 1, that's 12, so it's 12, like that. Then here it's 90x is equals to 12. We divide throughout by 90, so x will be, so you divide now. When you divide that, it is going to give you what? It is going to give you 12 over 90. We can simplify there, 12 there, 2 there, it's 6, 2 there is 45, let's use 3 there is 2, 3 there is what? 15, so 15, like that. So the answer is 2 over 15 in the form of a over b, like that. So you are done like that. Simple, they are very simple. So you just, provided you follow these steps, you will not get lost. So the first goal is to make in short, you can do this. The first goal is to make the traced number, of which it is the repeating pattern, to the other side once. Then the second one also is to the first one is to make the number which are independent perfect, to make them on the left side. So let me give you another example. Let's say we have 6.156. So the trace number is now 56. That's a repeating number. So what we are going to do is we say let x, all right, so we say let x is equal to let x be equal to what? Let x be equal to the same thing which you have, the 6.156, like that bar. All right, so that's ours. So how are we going to move this number to the other side as well of the point? So we are going to multiply times 10, so that will be 10x is equal to is equals to 1.56, like that bar. So that's our equation 1. Equation 2, now our goal is to make this to the other side as well of the point. So what number can we multiply? Is 100, so we multiply 100 this point. So we multiply equation 2 1 by 100, so we say 1 by 100, like that. So we it will be 1000, right, is equal to, when you multiply that one, 156 point again 56, because it was repeating and you have just brought the other on the other side. So now you subtract now 1, so 1 from 2, like that. All right, so when you subtract that, we are going to get 1000 x is equal to 6156.56. all right, so from there, then there is equation 1 is 10x, so 10x like that is equal to 61.56, like that. All right, so when you subtract that, we are going to have, what is 1000 minus 10? That's 990, right? X, so that's 990x. okay, so then what if we subtract this side now? 6 minus 50, that's 0. So in short, there it will give us 5. Then when we subtract that one, no, it will be 6 because it will be 11 there when we take the one other side. So that will be 5. Then 9, 15, which is 9. You just subtract 1 minus that. So 6 minus that, that's 5. Then 5 minus that, that's, we'll put 15. They are 9. So from there, then we'll put, then that will be just 60. All right, so now divide throughout 990, then 990, like that. So our x now will be, when we use 5 there, 5 there, it's 12, 19, like that, over 5 there is 198, like that. So this is where I can simplify to the fullest. That's where I end my thinking. You can still do it if you still have the goal, but I feel like this is the end. So all right, so that's in the form of a over b, like that. So that's about relational, something like that. So we can give another example if you want. Let's give another example. So let's say we have 517 bar, like that. It's still the same thing. It is still the same thing, provided you know what to do. So the first goal is to be this side. That will be your equation number 1. Then the other one is to make this the whole lot of this side to the other side as well. Then you will remain again with this 17 bar. Then that will be your equation 2. Then subtract 2 1 from 2. all right, so that is it. Then you'll be able to find your, so that is it. So let's get started, and let's get started into proving now irrational numbers. So irrational numbers now. All right, so we said irrational numbers, there will be numbers that can be in the form of a over b. We can't express in this form. Instead, there will be number be found, let's say root 2. When you press it, it will give you, let's say 3.216138213. So you can't trace the pattern, so those will be irrational numbers. All right, so we'll be proving whether a number is irrational. So example of rational number, let's say root 3, root 5, root 7, like that. Let's say 2 plus 5, like that. All this one is giving irrational. This can be rational, but when you add, you still result into irrational. All right, so don't get confused. So even if I give you to say 2 point plus 6, this is still irrational because of this thing which is supporting there. So don't even get what's this, don't get worried about to say they have put something not what we learned. So yeah, that is it. Then let's say we are given to say prove root 2 is irrational. All right, so this mathematics will be using calculation, I mean words. So we start like this. Now answering. All right, so you say suppose root 2 is rational, right? Like that. It can be expressed in the form a over b. All right, b is not equal to 0. So you just want to prove. So now what you are going to do is we are going to express now in the form of a over b. So we start like that. So we use contradiction method. It's always contradicting to what we are starting. All right, so we are saying suppose root 2 is irrational. Okay, suppose root 2 is irrational, so it can be expressed in the form of a over b. That's a statement we give. All right, in the form of a over b. All right, so and where a and b are in their lowest term. All right, so meaning that they can't be divided further. There's no other factor that can be used. That's what I mean when I say they are in their lowest term. So that's what you write. So then you start the same root which can be expressed in the form of a over b. So what are we going to do here? We square both sides, right? So when you square both sides, then you have here, then it's equals to, when that will be a squared over that will be b squared, like that. All right, so you can write there, that will be now 2b squared is equal to a squared, or I can say that's a squared is equal to 2b squared. All right, so now you make another statement. When you reach here, this is another statement that you write. Since a has a common factor of 2 because of these 2, all right, since a has a common factor of 2 like that, so say since a squared has a common factor of 2, comma, it means that, or let me say meaning that it is an even, all right, even number. So it is divisible by, it is divisible by 2, like that. All right, so it is divisible by 2. That's the meaning. So once it is divisible by 2, all right, it is divisible by 2. So by the above statement that you have made, it also means that a itself, a there it was a squared, now a again is also divisible by 2. So this is the statement that you make. Since a squared has a common factor of 2, meaning that it is an even, all right, an even number, so it is divisible by 2, and also a, just a itself, it is also divisible by 2. That's a meaning statement here. You can divide that. Then from there now we are going to say, after doing this, right, after showing this, we are going now to say, we make another statement. Allow me to lab this. We make another statement. So mind you, write this somewhere. So we make another statement. We say there exists an integer in the form of and b, which is the member of just integers k. Let's say k exists, which is a member of just the integers. All right. So since it is a member, since it is a member, since we have a something like that, since it is obeying this division, so we can say there exists a number, there exists a number that is just that we are going to express in the form of a should be equal to 2k, like that, because k will be just a constant number. So you always write this. All right. So since you write like this always, then what I'm going to do is we substitute. So this is our equation 1, by the way. All right, that's our equation 1. So we substitute. So when you substitute there, so meaning that we had a squared is equals to 2b squared, like that. When we put a there, our a now is there, so it will be 2k squared, like that, which is equal to 2b squared. So what you do is now is square, so that will be 4k squared is equal to 2b squared, like that. All right. So you put the same pattern. Allow me to write. So you copy this somewhere. It's a bit of complicated, but it's by word. That's how contradiction works. All right. So what you do is now you say you can now see this. That's 4k squared is equal to 2b squared, like that. So after doing this, you can now do what? Simplify. You divide throughout by 2. You see that 2 is divisible. So that is it, b squared, then that will be 2k squared, like that. Have you seen? So meaning that b is also which implies that b is divisible by 2. So this means that b is divisible, b is also divisible by 2. All right. So that's b squared is also divisible by 2. All right. So you can divide that b by 2. That's the meaning. So since b is also divisible by 2, what we are going to do is now, meaning that the b also is also divisible if we were to let them into just normal. So b is also divisible by 2, like that. Okay. Now that, so another statement, now that 2, all right, the same 2 we have just from proving, now that 2 is now a factor. So now that 2 is a factor of and b, like that. So now that this 2 is a factor of a and b, which contradict our assumption that assumption that A and B have no common factor, because we say have no common factor. So A and B doesn't have common factor. That's what we said. They are in the lowest term. So meaning that they are in lowest term, meaning that they don't have any common factor with them. So that is it. So the finally, allow me to say finally, by above proof, so it is now contradicting our assumption. So by above proof, we can say root 2 is irrational, like that. So this method is called proof by contradiction. So it is always contradicting our statements, and once we, so you state, when you start solving, you say we prove by contradiction method. Suppose this one is rational, we express in the form of A over B. So that is for the case whereby you are just given a single number. All right, so let me just give you another example. Let's say we are saying now prove that root 3 is irrational. All right, so it's just the same case. So what we do is, suppose you state a statement to say suppose, so these are solutions. Suppose 2 root 3 is rational, like that. All right, so if it is rational, then it be expressed in the form of A, so it can be equal to rational, which is A over B, and B is not equal to 0, like that. All right, all right. So now these are the steps that we are taking now. So we can now square both sides so that we remove that root. So that will be just 3 is equal to A squared over B squared. All right, so from there, then what we do is, now that will be now A squared is equal to 3B, like that. All right, so that's what we are going to do. So that's our other statement. So now from here you say this imply that this imply that H is divisible by 3, like that. All right, so it's divisible by 3. So when you are giving this statement to say suppose this one, suppose is irrational. All right, so is irrational, like that, and so you are supposed to write and A, B have no common factor. All right, so suppose they don't have common factor with them. When you have A over B, they should not have a common factor with them. So that's the statement. So this implies that A is divisible by 3, meaning that A just itself, so here it was A squared, A just itself is divisible by 3 again. All right, so that's the statement you give. Okay, that's the statement you give. So after you give this statement, now what do? You do this. Allow me to lab here. So allow me to lab. just there. I've run out of space. Alright, so a is also divisible by 3, meaning that there exists an integer which is a member of integers. There exists a constant number which is k. So meaning that a can be the form of a is equals to 3k, like that. Alright, so we substitute now in that equation, which is a squared is equal to 3k, like that. I mean 3b squared, the equation that we have just left. So we'll replace now where a is there. Alright, so replace a there, so that will be 3k, like that. Alright, by the way, so square then is equals to 3k, like that. Alright, squared, no, that's b squared. Then from there, then that will be 9k squared is equal to 3b squared. Have you seen? We can divide now throughout. That will be squared is equal to you divide that 3k squared. So meaning that you bring the same statement to say this implies that squared is divisible by 3. Alright, meaning that b is also divisible by 3, like that. Alright, so if this exists, meaning that a and b, that's another statement now, a and b have a common factor 3, which contradicts our assumption that they don't have any common factor in their lowest term. So this proves that, which contradict our statement. Alright, which contradict our statement that they don't have common factors, hence it's irrational. So T3 is irrational. So that is it. You lab. All right. So suppose you are given in this form now. Suppose you are given in this form to say, let's say, prove that root 5 minus 1 is irrational. So for this one is very simple. You make a statement to say, suppose root 5 minus 1 is irrational. All right. It can be expressed in the form of a over b. You write that is statement. It can be expressed in the form a over b, and where b is not equal to 0. All right. So now 5, this is 5 by the way, minus 1 is equal to a over b, like that. So meaning that we cross the other one there, so it will be a over b plus 1. So we can now group the right term. So we simplify there. That would be b into that, that's the a. Then that's 1 into b, that's 1. B times 1, that's b. So now this is simple when you find it like this. So it has come, this is irrational. So now that root 3 is irrational. All right. So now that root 3 is irrational, comma, it can't be so it can't be equal to rational, because what we have just found on the right side is just in the form of a over b, where these a and b are integers. So if they are just numbers, meaning that they can produce something like a over b. All right, so that's rational now. So we can't have a situation whereby irrational is equal to irrational. So this contradict our assumption that root 5 1 is rational. All right, so this contradict, in short, we are saying irrational can be equal to rational, so that's why we are saying it contradicts our assumption to say suppose it is rational. All right, so that's how you'll be solving this. Thank you very much for watching the video. Do the same and also go through the other pamphlet that you know, but this is the very way you can approach it. You can have other ways of writing statements, but master what is supposed to be written. I mean, the information that is supposed to be put on a paper, master it, please. Otherwise, thank you very much for watching the video.